We're all sure you guys.
Come on.
Are we taking notes?
Yep, 20 minutes worth.
Okay, excited.
Is the test or quiz long?
No, about 10 questions maybe? It's like probably 15-minute quiz, maybe 20, if you're 25 if you're really slow. Okay, so this is 3-4, day 1. Okay, like I said, we're going to be talking about spinning objects, things that turn, wheels, propellers, anything that's turning. All right? So, a Ferris wheel, yes, we'll be talking Ferris wheel. Oh, tilt-a-whirl. I don't know if we're going tilt-a-whirl.
You're killing me.
So,
How many people are there? I'm aware. Okay.
I forgot what you did.
We won the best ball, but I Googled
okay,
balls.
so the kinds of velocities we're going to be talking about. Save your conversation.
It's really important.
How fast is point P moving? What kind of unit would that be, or what am I talking about when I say how fast something is moving? What's the physics word for it?
Velocity.
Velocity. We're talking velocity. So, in this case, it would be linear velocity, which we will use big V. Give me some units of some velocities you are familiar with. Miles per hour. So examples. Miles per hour. Give me another one that could be a velocity.
Feet per second.
Feet per second. There's a lot of them. Give me one more. Meters per second. What do they all have in common in terms of, like, what do all of the numerators represent, what do all of the denominators represent? Distance and time. So linear velocity is anything that has some kind of a distance unit divided by a time unit. So when we do the problems, you're going to be focused. I want you to focus on the labels, the intervals, not the intervals, the labels, so you know what we're talking about here. So anything that has distance over time is going to be our big V value. Justin?
You don't have to worry about direction.
No direction stuff. Okay. So that's one kind of velocity. We can talk about how fast that point is moving. This angle theta, that will also change. As that point moves, the angle gets bigger. Okay? So there's another kind of velocity we're going to talk about, and it's angular velocity. Angular velocity is how fast theta is changing. Okay, the symbol or the letter that they use for angular velocity is a Greek letter, omega, also known as butt cheeks. Angular velocity is your W. Butt cheeks.
What was that? It's always one.
Okay, so this, your units for this is going to be some kind of a, well, because we're talking radians here, it's going to be radians over time. It's still a velocity, so it has to have a per time, and it's how fast the radians are changing over time. Okay, so our formulas. Big V. I want distance over time. Well, as P moves along this circle, what have we been calling, and what is your quiz on today? What's this distance called? Arc length, S. So it's S divided by time. How do you get S? What's the formula for S?
equals r times theta.
Well, the formula we're going to use is r times theta divided by time. There's your big V formula. R times theta divided by time. What do you have to remember about theta? Has to be in radians. So if they give you degrees, we have to convert, just like on today's quiz. So theta must be in radians.
Like any other budget,
Yeah.
or,
Okay? Now, angular velocity was the W.
because all the other budgets have to be.
And I told you it was just radians over time, so this one's just theta divided by time. Now, what this does for us is it gives us another version for linear velocity. Do you see the theta over t here in linear velocity?
Yeah.
What can I replace that with? What's theta over t equal to? W. So another velocity formula, not used very often, I guess I should have left a little bit of room there, would be r times w. So we have two velocity formulas, this one and this one. Two linear velocity formulas. Okay, so we're just going to do a bit of simple problems today, just kind of algebra, plug and chug, solving for an unknown. So our first example, find the angular velocity of a pulley that turns 2 pi over 5 radians in 10 seconds. And I want an exact answer with pi. And a decimal answer. I want both. Exact answer and decimal. Okay, so it's all about words and the units that are going to tell you what everything is, so focus on that. So first of all, it says find angular velocity. What's our symbol for angular velocity? The W. 2 pi over 5 radians. What have we called that all the time? What's our symbol for it? Theta. That is theta because it is radians. And 10 seconds, that's a time value, that's a t. So, do you have a formula that relates those three variables together? The only, well, there's this one, but we've got W equals theta over t. W is your angular velocity, that's what we're trying to find. So this is my formula I'm going to use, based on what I pulled out of the problem. So I'll start with the formula. So, I don't know W, that's what I'm trying to find. I know that theta is 2 pi over 5.
Wow.
Then it says divide by the time. The time is 10. We need to work with this. I want an exact answer. So, I've got a fraction within a fraction. So what's our process to do that?
You multiply by the reciprocal.
So if I made the 10 a fraction
No
by
problem.
putting it over 1, my next step then says, keep the numerator the same. Actually, 7th grade math says, keep the numerator the same. Flip the denominator over. And then just simplify this. What can I reduce before I multiply? The 2 and the 10 can reduce. And when I multiply fractions, I multiply numerators together. So I get pi over 25. What unit should I have on my answer? I found an angular velocity.
Theta. Radians per second.
Radians per second. Because remember, it's always radians over some time value. My time value was seconds, so it's radians per second.
Can you write R/S?
Sure. Number 2.
You forgot to do exact, or not exact.
Oh, I forgot to do the decimal. What's the decimal for it? I could go right back to here. In case I made a mistake, I could go right here and do my 2 pi divided by 5 divided by 10. I went right back to here, in case I made a mistake in all this mumbo jumbo.
Wait, if you like turn that into a fraction, what is
It will not, because pi is in there. Pi is irrational. Pi can't go to a fraction. So anytime I multiply by pi, it will be impossible. It will not do it. If I left the pi out though, 2 divided by 5 divided by 10, and then stick my pi on the answer, it does.
That's correct.
Yep, because yeah, that's where it was to start with. So you could get by without knowing your junior high fractions. So our approximate is 0.126 radians per second. Okay, try another. I'm quitting at 25.2. So if angular velocity is 3 pi over 4 radians per minute, and this thing moves for 6 minutes,
What was that?
if angular velocity is 3 pi over 4 radians per minute, and it moves for 6 minutes, how many radians did it turn through? So through how many radians?
We can use the same formula.
Radians
Thanks, Alex.
did it turn? Okay, look at units so you know what variable they're giving you. Because this is 3 pi over 4 radians per minute, what is the 3 pi over 4? What do we have, what do we call radians per time? What letter?
Butt cheeks.
W. That's what you have to get good at. 6 minutes, that's your time. The question says through how many radians? What are we calling radians? Theta. So it's the same formula, like Kenley noticed. W equals theta over time. Do I know the W this time? Yes. The W, I'm going to substitute into 3 pi over 4. The theta, I don't know. Theta. The time was 6 minutes. Now it's your algebra skill. How do you solve this for theta? You can multiply by 6. Or you can do cross products. Times by 6 is going to get us there quicker. So if we multiply by 6 over 1, multiply by 6 over, anytime I have a fraction, when I bring my whole number over, I just put it over 1 so I can see what lines up. So if I reduce, that's a 2, that's a 3, I get theta equals 9 pi what? Over 2 what? Lost my 2.
Radians.
Radians. If I want it exact. If I want the decimal, I'll just type it in, but I don't want the decimal. Save some time.
What's the W velocity?
Angular velocity. How many radians per time? How fast the angle is changing. So we talk 2 kinds of velocity. in this chapter.
Get on.
I'm not gonna have time to finish my quiz.
Oh yeah, I'm going to the 7, I said.
Well, we can always go into lunch a little bit if we need it, right?
No.
Emily wasn't?
You won't need extra time.
Yeah.
Find the time.
Yeah.
But I finished in
If-
time.
It passes through
I thought you were
3 pi over 8 radians and is moving at pi over 32 radians per minute. And is moving. Find the time if it, whatever it is, passes through 3 pi over 8 radians and is moving at pi over 32 radians per minute. Didn't give you any indication what these were. You have to focus on the unit, the label, to tell what they are. So, we'll obviously find the time. I'm looking for T. That one's easy. All right, Austin, what do you think?
I say the 3 pi over 8, theta,
Is the theta, because it's radians.
and then the pi over 32 is the 1, but she puts
The W, omega.
Omega.
Because it's radians per time, that's our W, that's our angular velocity. Then we're looking for T. So it's the same formula again. W equals theta over T. Substituting in for the two parts that we know the W is pi over 32. The theta is unknown. Nope, the theta is known. That's 3 pi over 8. And that is all over time. It's the fraction within the fraction that's the challenge. That's what gets me. We're going to take a couple of steps to get here. So, what I want to do is take care of this fraction within a fraction and get this one side to be one fraction. How do I do that? So forget about this for now. What do I do with a fraction divided by this whole number, or this letter?
No, you didn't like to do that.
Put it over 1, and I'm going to flip that over and multiply it by the top. So just to get a single fraction over here instead of a fraction within a fraction. So I'm going to keep the pi over 32. This will now become 3 pi over 8 multiplied by 1 over t. So far so good?
Yeah.
Austin, you look lost. Because I got to multiply by the reciprocal of the bottom. So I put a 1 under it, so I had a fraction over a fraction. 7th grade math says keep the top one the same, flip the bottom one over. So I'm just simplifying this side, so that I get just a single fraction here. So I'm just going to take baby steps through here so I don't lose anybody. So this is 3 pi over 8t. At this point you have options. I like cross products. When you've got two fractions equal to each other, that's just proportions. Cross products are equal. So my cross product here is 8 pi times t equals 32 times 3 times pi. 32 times 3 is 96 pi. How do I solve for t? Divide by 8 pi. Are there other ways to do this? Yes. So the pi's cancel.
12.
12 what?
And then just 12 minutes.
12 minutes. So algebra's a bit of a challenge today, I think. Not so much the trig, plugging in the, knowing the formula, it's the algebra. Okay, last one. Oh, wait till you get, I can get this one. That's usually the one where the T ends up in the bottom, that's the one
Yeah, I
that
got that
stumps
on my
everybody.
own.
All on your own? Awesome.
Yeah.
Okay.
Yeah.
All right. If it is moving,
What is it?
I don't know,
Define it.
at 18 feet per second, its radius is 3 feet. Radius. Can you find its angular velocity?
Why are we not working with linear velocity?
Okay. So that, it didn't tell you what anything was. You have to focus on the label to tell what it is. 18 feet per second. That's a velocity, but which velocity is it? Is it the angular velocity or is it the linear velocity?
Linear.
It's linear because it's a distance. Feet is a distance over time. This is big V. That's big V. Its radius is 3 feet. Okay, that's easy enough to pick out. We're asked to find its angular velocity. What's the symbol for angular velocity? W. Do you have a formula that relates V, R, and W? If you look at your beginning of the notes, there's two big V formulas, and there is one that says V equals R times W. That's the hard part. What did they give me? What formula am I supposed to use? Today they're going to label everything for you very easy, but I'm just kind of leading you into the story problems where it's all kind of just thrown in there. So we substitute in. I've got 18. Radius is 3. W. Algebra is super easy. Here it's W equals 6 what?
Radians per second.
Radians per second. Okay. You did not forget everything. You have a nice note card. All right, I'll get the assignment here in a minute. Take out your review sheet. Is there anything you want to go over on that?
A freaking sweet note card.
You were gonna say Bob Hayes.
Anything on the review sheet for you?
Okay.
17. Not that I have one of those handy.
Yeah, we need to do some of those, but I have no idea.
I don't know what I did with them.
Never talking to you again.
Not the first time I've heard that.
17. Let's see, we got a wheel with a 22-inch radius. 2 points. Distance is 6. Radius is 22. Find the angle between them, between the 2 points. What formula are you going to use? R theta.
Wait, what are we doing right now?
17. There's questions. So the S is 6. The radius is 22. Solve for theta. I got to divide. What units would this theta be in right now? Radian. I've got all degree answers. What's the 2 steps to get from radians to degrees?
Divide by pi.
Divide by pi times by 180. You'll have the right answer. Yeah.
Okay, so like calculator.
Yep.
Like the 27 and 28.
Yep.
We like review that.
Yeah.
Okay, 27, you first have to know what mode you're going to be in. The interval tells me radian mode. Anytime I'm looking for an angle, I need an inverse button. So all I would do for this is be in radian mode and do inverse sine of that number.
Okay, and it would be the same thing as 28.
28 would be inverse tangent of that number.
Okay, and then what do you do for 29 and 30?
29, I would switch back to degree mode. I would do inverse cosine of the cosine ratio would be 1 over 8.3. So you always start with an inverse button, and then you put in the ratio for that function
On inverse cosine
of 1 over 8.392, blah, 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 blah.
On the quiz, is it gonna be like sine of S or sine of theta?
Same thing.
I know, but it's confusing.
I know, I
You
switched
taught
them
us
all, cause they
theta.
say, cause if it's the unit circle, the S is the theta, and I think that's just dumb. So I switched them mostly to theta, and on here I had the S's. Still just looking for an angle, even though it says that.
And then, the 21 through 23, I think it's because I wasn't here that day, it feels slow.
These exact values are on your circle sheet.
So you, like when it says 19 pi,
You have to turn that into degrees, cause I don't know where, because it's not on there, but if you turn it into degrees, it was, what was that in degrees? It was something largish.
It was, like,
You divide by
570.
570 degrees, so you gotta subtract 360 until you get down to something that is on your circle sheet.
okay.
Matt,
Are you 24?
24,
Go down with myself.
that's a radian, so I'd be in radian mode, tangent of that number, done. Austin,
15,
15, I'm gonna pass out the quiz, and if you still have questions, I'm gonna get to you. North of the equator, 55, south of the equator, 54, so this arc, I have to add those two angles together, not subtract. 109, divide by 180 times pi times the radius of the earth.
please. Okay.
Okay, if you still have questions, I'll get to you individually. Individually, otherwise we're starting.
Nice note card back, Casey. It's got like.
This is a long quiz. Don't think so.
One side.
Never know.
Do it on the bottom.
You're not taking it. There's one over there.
I know, it's hard to go.
That thing.
And I'll find your assignment.
You know what I mean, that's really wrong on that level.
Oh, yeah. Okay. You have to realize that when this wheel turns, 4 feet.
Is there homework?
There will be, yep. So that distance is the arc length, and that's the 4 feet, so that's my S value.
So we're using SI.
Yep, and the trick on this one is this is inches and feet. So you have to convert that to inches by multiplying by 12. Yes, equals, this should be 13 theta, not 15. That's why, then you divide by 13, that'll be radians, and then do the 2 steps to
Do you
get
do
the degrees.
the same thing that you did
Mhm.
this one?
Yep.
Okay, and then, for this one,
Mhm. Subtends an angle, so you've got this tree. Subtends an angle means I'm standing far away from it, so I got the center, and then it gives me the angle to the top and the bottom. Let me finish. 480 meters away, 5 degrees,
Oh, like.
S equals R theta, yep.
Wait,
Because the height is gonna be that curve, we're gonna say the height is that curve distance, so
oh,
it's
so
an S
this
equals.
would be, that's R.
That's the radius, and you have to turn that into radians.
Oh, okay, okay.
What's your question?
Does it matter if...
When does it matter what mode you're in?
If you have to click sine, cosine, or tangent?
That's when you need to be aware of your mode, when you touch sine, cosine, and tangent.
How many places you want to go?
Don't care.
Oh, wait, actually, I think I.
Yep. Care about your mode when you're gonna touch sine, cosine, and tangent. Very good. BECCA?
What?
Yeah, BECCA?
Yeah, you said BA.
Oh, BE, I meant BE, I wrote BE.
Backup.
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 Backup. Trick. There's your assignment for afterwards. Not overkill. I never stopped the recording.